Select the major product of the following reaction sequence. So what we want to do to approach a problem like this is look at what we are starting with, and we can see that we have an alcohol, and specifically we have a primary alcohol. And then we're probably going to want to go through these step by step and see what's formed from each of these reaction steps. So in the first one, we're using PCC, so that's pyridinium chlorochromate, and dichloromethane solvent, CH2Cl2 solvent. So hopefully we recall that these are conditions to take a primary alcohol and oxidize them to an aldehyde. So this carbon atom here is going to be oxidized to an aldehyde. So you can draw that aldehyde. So that's the product of this first step. And then in the second step, we are adding in a Grignard reagent, which is a strong base and a strong nucleophile. And so we can represent that carbon-magnesium bond almost as though it was an ionic bond. So I'm going to draw it. Basically, I turned it around so I can see where this negative charge is, because that's my nucleophile that's going to attack the electrophilic carbonyl of that aldehyde. And so we have the magnesium bromide kind of hanging around there as a counterion. And you could actually represent that as a carbon-magnesium covalent bond. It's actually just a very, very polar covalent bond. All right, so we've got this nucleophile, and we know that carbonyl carbons are electrophilic. So this nucleophile is going to attack that carbonyl carbon, and it is going to break the pi bond, putting those electrons onto the oxygen. So what we see then, what we can form as a product here is we see that we have, so this is that carbon atom. It has the oxygen, and it now has a negative charge because we put an extra lone pair of electrons on there. We still have the hydrogen, which you could draw in or leave it off because in a skeletal structure, it's understood to be there. And then we have added this 1, 2, 3 carbon atom chain. So 1, 2, 3 carbon atoms to that chain. And so this is the tetrahedral intermediate. And so we always want to look at our tetrahedral intermediate carefully, because we know that if we had a good leaving group on here, that these electrons could come down to reform that carbonyl and kick off the leaving group. But what we have here is carbon, hydrogen, carbon. None of those are good leaving groups because they would be too strongly basic. So nothing else is going to happen in this step until we add in that H3O+. And when we do that, we will protonate this alkoxide. So we'll be adding a hydrogen so that we get a neutral alcohol as the product. And so we can draw this. I'm going to draw the skeletal structure. So we're going to understand that that hydrogen is there. The hydrogen on the oxygen, we do have to draw that in. And then we have the 1, 2, 3 carbon atom chain that we added. And so if we take a look at our options, we can see that this matches the answer A.